Hello everyone, welcome back to our Mechanics of Materials video lecture series. In today's session, we are going to learn one of the most powerful classical methods in structural analysis, that is Theorem of Three Moments. This theorem is widely used for analyzing continuous beams, especially in exams and real-world bridge structures. By the end of this session, we will understand about what the theorem is, why it is used, where it is applied. Let's begin and dive into the topic directly. So let's recall an important concept, that is continuous beams. A continuous beam is a beam that extends over more than two supports, forming multiple spans. What happens here? The beam is continuous across the supports. The loads act on different spans, and bending moments develop at the indeterminate supports. Because of this, the structure becomes statically indeterminate. And the problem is we cannot solve using only equilibrium equations. So we need special methods. One such method is Theorem of Three Moments. In this session, we will discuss about the concept of three-moment theorem, conditions of applicability, importance in continuous beam analysis. Let's explore the concept step by step. The theorem of three moments establishes a relationship between bending moments at three consecutive supports of a continuous beam. In simple terms, it connects the moments at supports A, B, and C, that is the three support on a continuous beam. Why this is useful? Because instead of solving many unknowns, we convert the problem into single equation involving moments. And the key idea, it relates the span lengths, loads acting on spans, and moments at supports. So this theorem helps us to simplify complex indeterminate problems, solve them using mathematical relationship. This is why it is widely used in advanced structural analysis for different structures. So with regards to the Clapeyron theorem, this theorem is also known as Theorem of Three Moments. Let's understand why it is important. It is important because it avoids complicated displacement calculations. It reduces mathematical complexity and it is suitable for manual calculations. It is very important for this kind of problems comes in university exam, competitive exams and bridge analysis. Engineers prefer this method because it is efficient, reliable and practical. It connects theory with real-world applications. The theorem is valid only under certain conditions. The conditions are: the beam must be continuous, it should have multiple spans, the material should obey Hooke's law, stress is proportional to strain, and flexural rigidity is constant, the same material in cross section throughout the span of the beam. And supports should not undergo large settlements. No significant movement at the support should be noticed. Why these are the conditions very important? Because the theorem is derived based on these assumptions. If conditions are violated, results may not be accurate. Now let's look at the real life applications of this theorem. It is used in multiple span bridges in which the loads are distributed across multiple supports, and also in continuous reinforced cement concrete beams, which is used in building frames, and also in highway overpasses, which require stability and load sharing. Why this theorem here? Because these structures are continuous, have multiple supports and are indeterminate. So the theorem becomes a powerful tool for engineers in solving real-world complex problems. So let's summarize today's concept. In today's video lecture series, we have learnt about continuous beams which are statically indeterminate and the theorem of three moments or Clapeyron's theorem, which relates moments at three supports, which simplifies complex problems and applicable under specific conditions, which are widely used in practical structures. In simple words, this theorem helps convert a difficult problem into a manageable one. Next, we move to the curiosity challenge. Now, let's think critically. Why do bending moments develop at indeterminate supports, even no external moment is applied there? Hint, it is due to continuity of beam, load transfer between spans, and restriction of rotation. Pause and discuss with your friends for answers. Let's test your understanding with two simple questions. First question is, the theorem relates moments at, answer is three consecutive supports. And second question is, this theorem is mainly used for, the answer is continuous beams. So for further reading, let's refer to the following standard textbook, online resources, and practice problems. This theorem is a foundation for advanced structure analysis methods. Thank you for watching this video. Do like, share, and subscribe. See you in the next lecture. Thank you. Have a good day.